Hi, I thought I'd share with you a quick demo of some work I was doing this morning with Google's Gemini 2.5 Flash. Once again, this is free, available to anybody. I thought I would do a little bit of an investigation so that I could demonstrate that the hockey stick type graphs, the exponential growth that we see in things like compute power, density of transistors on a microchip, this kind of thing that we're all very used to in the computer world, is happening across multiple domains, not necessarily computational ones. So I thought I would use Gemini to do a bit of research, and this is a really good example of how you can use Gemini to spit out reasonable bits of graduate level research. Now, this probably would have taken me the better part of between half a day and a day to do myself. So here's the query. Hi Gemini, inspired by the work of Ray Kurzweil, I'm looking for a list of things that have got an exponential hockey stick curve. I'd like to make you a range of suggestions. I'd like you to make a range of suggestions, potentially from STEM fields. So that's science, technology, engineering, mathematics, but also maybe arts and philosophy, geography, human behavior, markets, finance. So I just threw a whole bunch of ideas at it. So I said anything like this, but please go looking for me. The caveat is that the data must be verifiable with links to sources. You will need to do an in-depth internet search to find the data. If you can't verify it, I don't want to. Present your findings in a table. I'm on the left, blah, blah, blah. Okay, so then I click the deep research button and I click go. So this down the left here is the sort of briefing document that it comes out when you go for deep research. It formulates a brief for you to do before you get it to do it, because what it's about to do is quite in depth, and you really want to get it right. It's going to spend a while doing it. So then on the right, I'm just going to show you quickly the sources used in this report. So there are a lot of sources here, but you can actually watch it working. And at the height of its querying, it had hit 80 separate websites. That's a massive amount of research. And just imagine the amount of time it would take you to Google 80 websites and decide whether or not the data within them was useful, whether it could be verified, this kind of thing. So let's just go up to the top here to show what it's done. So look at this. It's given us an executive summary right at the top. This is perfect. A comprehensive analysis of various phenomena exhibiting exponential hockey stick growth patterns. Drawing on the foundational work of Ray Kurzweil on the law of accelerating returns. Okay. So this is fantastic. Somebody that doesn't know. See, I knew what I was talking about when I asked it for this, but it's written the report for somebody that potentially doesn't know. So it then goes on to explain things about exponential growth and some key aspects of Kurzweil's theory. Okay, so that was what I got, and I was like, that's fine. Now, what I need to do is I need to be able to visualize it so that I can actually show people what's going on, because you can read the whole of Kurzweil's book, The Singularity, miss out the graphs. You just don't get a picture in your head of how significant this all is. So okay, I went over and I well, in fact, it just continues like this. I've been chatting with Gemini to get this for probably a couple of hours now. So this is a couple of hours work to get from the initial large query, which took Gemini about 5 minutes to generate, maybe a little longer, and this. Okay, so what are we looking at here? I've asked it to plot all of the items that it found verifiable stuff for on a graph. Now, obviously, the kinds of things that are being graphed here are not remotely similar in some cases. And so what I asked it to do was give me a scale on the left that was appropriate for each line so that we could superimpose the lines and get some mathematical accuracy of it was, but of the implication, just in terms of looking at the graph. And what I asked it to do was, I wanted to know, initially, this was the first table that it put out, I wanted to know what year the rate of doubling occurred within a 24-month period. And I went from that to, look, let's just graph this because we can actually see it. This is what I got out. I asked for several interactive elements. So if we pick one at random here, let's look at the qubit count in quantum processors. I'm going to click that. It scrolls up to the top and it gives me a little glow for that. So I know that's there. And then if I mouse over it, there we go. Okay, I'm going to choose another one. US sustainable aviation fuel production. That's looking very good. AI computing power, training compute. This kicked off seriously in, it looks like around about 2012. And again, look, hey, all the primary research was done by AI. You need to verify your sources. I haven't. This is just being done for the sake of being able to show you a graph, and because I know from reading Kurzweil's book, which is very well researched, that the data here is representative, if not entirely accurate. I mean, here's one that is very well tracked. Transistor count, Moore's law. You can see there are things going on with Moore's law. I mean, it's often been said that they're going to hit the sort of the outer edges of what's possible in terms of making things smaller. But just to give you one example, they started printing microchips on a single layer, and then they got to the point where squeeze any more into that space. So they just decided to make more than one layer and to put wires vertically between them. And suddenly the problem goes away. So you get to a point of the graph like this, and you're like, okay, we can't do any more. Maybe Moore's law doesn't apply anymore. And then this happens because you've solved the problem, but actually you've potentially gone one step beyond there. And then you figure out a new way of lithography where you can fit more transistors on, and then the problem punts further into the future, and so on, like that. So this is all very well and good. And, you know, okay, what we're seeing here is a spread from, around about 2012 through to 2040 of these hockey sticks. But why? The subtitle and the sort of the Kurzweilian thesis is that you're going to hit a singularity of growth across all different sectors, and so I've used the fancy word eschaton. It's sort of the end of things, if you will, the end of history, the end of time, the end of technological development. But it's not really the end of anything. It's simply a point beyond which it's really, really hard to predict the future, because most of our models for what's happened before don't apply anymore. And the way I wanted to show you this was just by zooming out. So I've got a button here. Again, this is just natural language. I just asked Gemini to do this. I fiddled with it a bit until it looked nice and it did what I wanted. Click zoom. And so now we've zoomed out from the year 1900 to the year 2070. And you can see that the graph has packed together, right? So the further out we zoom, single line. And you can see that we view the course of human history through a very unique lens, and that lens is how long we're alive for. And it's only if you study history that you start to get a bigger lens. You have this capacity to zoom out. And so here we've only zoomed out to the extent that we're encompassing maybe three lifetimes. If we zoom out the same again, our lines, they're going to condense down even further. By the time we've zoomed out to, let's say, the 1500s, this is just going to look like a single line on the graph. Now, where it comes, nobody's, there is no way of telling. From this graph, it looks like somewhere between the year 2035 and 2040. And it's just remarkable. Look at, say, global precision fermentation ingredients market value. There it is, bang in the middle. It's really weird. You can't predict particularly what it is that's going to be falling into this graph. But there's like Medicare beneficiary usage of remote patient monitoring. I would have to go away and read to find out what that even is. So there's just another quick example of using Gemini to visualize data, to create an HTML. Just upload this on a website, and I might do that for everyone. How you can get it to do primary research for you, how you can get it to kick off your own ideas for further research. And of course, just remembering all the time that you need to go away and verify your facts or the data that it gives you.